Section 8 of Science and the Modern World by Alfred Whitehead. This LibriVox recording is in the public domain. Chapter 8. The Quantum Theory. The theory of relativity has justly excited a great amount of public attention, but for all its importance, it has not been the topic which has chiefly absorbed the recent interest of physicists. Without question, that position is held by the quantum theory. The point of interest in this theory is that, according to it, some effects which appear essentially capable of gradual increase or gradual diminution are in reality to be increased or decreased only by certain definite jumps. It is as though you could walk at 3 miles per hour or at 4 miles per hour, but not at 3.5 miles per hour. The effects in question are concerned with the radiation of light from a molecule which has been excited by some collision. Light consists of waves of vibration in the electromagnetic field. After a complete wave has passed a given point, everything at that point is restored to its original state and is ready for the next wave which follows on. Picture to yourselves the waves on the ocean and reckon from crest to crest of successive waves. The number of waves which pass a given point in 1 second is called the frequency of that system of waves. A system of light waves of definite frequency corresponds to a definite color in the spectrum. Now a molecule, when excited, vibrates with a certain number of definite frequencies. In other words, there are a definite set of modes of vibration of the molecule, and each mode of vibration has one definite frequency. Each mode of vibration can stir up in the electromagnetic field waves of its own frequency. These waves carry away the energy of the vibration, so that finally, when such waves are in being, the molecule loses the energy of its excitement and the waves cease. Thus a molecule can radiate light of certain definite colors, that is to say, of certain definite frequencies. You would think that each mode of vibration could be excited to any intensity, so that the energy carried away by light of that frequency could be of any amount. But this is not the case. There appear to be certain minimum amounts of energy which cannot be subdivided. The case is analogous to that of a citizen of the United States who, in paying his debts in the currency of his country, cannot subdivide a cent so as to correspond to some minute subdivision of the goods obtained. The cent corresponds to the minimum quantity of the light energy, and the goods obtained correspond to the energy of the exciting cause. This exciting cause is either strong enough to procure the emission of 1 cent of energy, or fails to procure the emission of any energy whatsoever. In any case, the molecule will only emit an integral number of cents of energy. There is a further peculiarity which we can illustrate by bringing an Englishman onto the scene. He pays his debts in English currency, and his smallest unit is a farthing, which differs in value from the cent. The farthing is in fact about half a cent, to a very rough approximation. In the molecule, different modes of vibration have different frequencies. Compare each mode to a nation. One mode corresponds to the United States, and another mode corresponds to England. One mode can only radiate its energy in an integral number of cents, so that a cent of energy is the least it can pay out, whereas the other mode can only radiate its energy in an integral number of farthings, so that a farthing of energy is the least that it can pay out. Also, a rule can be found to tell us the relative value of the cent of energy of one mode to the farthing of energy of another mode. The rule is childishly simple. Each smallest coin of energy has a value in strict proportion to the frequency belonging to that mode. By this rule, and comparing farthings with cents, the frequency of an American would be about twice that of an Englishman. In other words, the American would do about twice as many things in a second as an Englishman. I must leave you to judge whether this corresponds to the reputed characters of the two nations. Also, I suggest that there are merits attaching to both ends of the solar spectrum. Sometimes you want red light and sometimes violet light. There has been, I hope, no great difficulty in comprehending what the quantum theory asserts about molecules. The perplexity arises from the effort to fit the theory into the current scientific picture of what is going on in the molecule or atom. It has been the basis of the materialistic theory that the happenings of nature are to be explained in terms of the locomotion of material. In accordance with this principle, the waves of light were explained in terms of the locomotion of a material ether, and the internal happenings of a molecule are now explained in terms of the locomotion of separate material parts. In respect to waves of light, the material ether has retreated to an indeterminate position in the background and is rarely talked about. But the principle is unquestioned as regards its application to the atom. For example, a neutral hydrogen atom is assumed to consist of at least 2 lumps of material. One lump is the nucleus consisting of a material called positive electricity, and the other is a single electron, which is negative electricity. The nucleus shows signs of being complex and of being subdivisible into smaller lumps, some of positive electricity and others electronic. The assumption is that whatever vibration takes place in the atom is to be attributed to the vibratory locomotion of some bit of material, detachable from the remainder. The difficulty with the quantum theory is that, on this hypothesis, we have to picture the atom as providing a limited number of definite grooves, which are the sole tracks along which vibration can take place, whereas the classical scientific picture provides none of these grooves. The quantum theory wants trolley cars with a limited number of routes, and the scientific picture provides horses galloping over prairies. The result is that the physical doctrine of the atom has got into a state which is strongly suggestive of the epicycles of astronomy before Copernicus. On the organic theory of nature, there are two sorts of vibrations which radically differ from each other. There is vibratory locomotion, and there is vibratory organic deformation, and the conditions for the two types of change are of a different character. In other words, there is vibratory locomotion of a given pattern as one whole, and there is vibratory change of pattern. A complete organism in the organic theory is what corresponds to a bit of material on the materialistic theory. There will be a primary genus comprising a number of species of organisms, such that each primary organism, belonging to a species of the primary genus, is not decomposable into subordinate organisms. I will call any organism of the primary genus a primate. There may be different species of primates. It must be kept in mind that we are dealing with the abstractions of physics. Accordingly, we are not thinking of what a primate is in itself, as a pattern arising from the prehension of the concrete aspects. Nor are we thinking of what a primate is for its environment, in respect to its concrete aspects prehended therein. We are thinking of these various aspects merely in so far as their effects on patterns and on locomotion are expressible in spatio-temporal terms. Accordingly, in the language of physics, the aspects of a primate are merely its contributions to the electromagnetic field. This is, in fact, exactly what we know of electrons and protons. An electron for us is merely the pattern of its aspects in its environment, so far as those aspects are relevant to the electromagnetic field. Now, in discussing the theory of relativity, we saw that the relative motion of two primates means simply that their organic patterns are utilizing diverse space-time systems. If two primates do not continue either mutually at rest or mutually in uniform relative motion, at least one of them is changing its intrinsic space-time system. The laws of motion express the conditions under which these changes of space-time systems are effected. The conditions for vibratory locomotion are founded upon these general laws of motion. But it is possible that certain species of primates are apt to go to pieces under conditions which lead them to effect changes of space-time systems. Such species would only experience a long range of endurance if they had succeeded in forming a favorable association among primates of different species, such that in this association the tendency to collapse is neutralized by the environment of the association. We can imagine the atomic nucleus as composed of a large number of primates of differing species, and perhaps with many primates of the same species, the whole association being such as to favor stability. An example of such an association is afforded by the association of a positive nucleus with negative electrons to obtain a neutral atom. The neutral atom is thereby shielded from any electric field which would otherwise produce changes in the space-time system of the atom. The requirements of physics now suggest an idea which is very consonant with the organic philosophical theory. I put it in the form of a question. Has our organic theory of endurance been tainted by the materialistic theory insofar as it assumes without question that endurance must mean undifferentiated sameness throughout the life history concerned? Perhaps you noticed that in a previous chapter I used the word reiteration as a synonym of endurance. It obviously is not quite synonymous in its meaning, and now I want to suggest that reiteration, where it differs from endurance, is more nearly what the organic theory requires. The difference is very analogous to that between the Galileans and the Aristotelians. Aristotle said rest, where Galileo added or uniform motion in a straight line. Thus, in the organic theory, a pattern need not endure in undifferentiated sameness through time. The pattern may be essentially one of aesthetic contrasts requiring a lapse of time for its unfolding. A tune is an example of such a pattern. Thus, the endurance of the pattern now means the reiteration of its succession of contrasts. This is obviously the most general notion of endurance on the organic theory, and reiteration is perhaps the word which expresses it with most directness. But when we translate this notion into the abstractions of physics, it at once becomes the technical notion of vibration. This vibration is not the vibratory locomotion. It is the vibration of organic deformation. There are certain indications in modern physics that for the role of corpuscular organisms at the base of the physical field, we require vibratory entities. Such corpuscles would be the corpuscles detected as expelled from the nuclei of atoms, which then dissolve into waves of light. We may conjecture that such a corpuscular body has no great stability of endurance when in isolation. Accordingly, an unfavorable environment leading to rapid changes in its proper space-time system, that is to say, an environment jolting it into violent accelerations, causes the corpuscles to go to pieces and dissolve into light waves of the same period of vibration. A proton, and perhaps an electron, would be an association of such primates, superposed on each other, with their frequencies and spatial dimensions so arranged as to promote the stability of the complex organism when jolted into accelerations of locomotion. The conditions for stability would give the associations of periods possible for protons. The expulsion of a primate would come from a jolt which leads the proton either to settle down into an alternative association or to generate a new primate by the aid of the energy received. A primate must be associated with a definite frequency of vibratory organic deformation, so that when it goes to pieces, it dissolves into light waves of the same frequency, which then carry off all its average energy. It is quite easy, as a particular hypothesis, to imagine stationary vibrations of the electromagnetic field of definite frequency, and directed radially to and from a centre, which, in accordance with the accepted electromagnetic laws, would consist of a vibratory spherical nucleus satisfying one set of conditions, and a vibratory external field satisfying another set of conditions. This is an example of vibratory organic deformation. Further, on this particular hypothesis, there are two ways of determining the subsidiary conditions so as to satisfy the ordinary requirements of mathematical physics. The total energy, according to one of these ways, would satisfy the quantum condition, so that it consists of an integral number of units or cents, which are such that the cent of energy of any primate is proportional to its frequency. I have not worked out the conditions for stability or for a stable association. I have mentioned the particular hypothesis by way of showing by example that the organic theory of nature affords possibilities for the reconsideration of ultimate physical laws, which are not open to the opposed materialistic theory. In this particular hypothesis of vibratory primates, the Maxwellian equations are supposed to hold throughout all space, including the interior of a proton. They express the laws governing the vibratory production and absorption of energy. The whole process for each primate issues in a certain average energy characteristic of the primate, and proportional to its mass. In fact, the energy is the mass. There are vibratory radial streams of energy, both without and within a primate. Within the primate, there are vibratory distributions of electric density. On the materialistic theory, such density marks the presence of material. On the organic theory of vibration, it marks the vibratory production of energy. Such production is restricted to the interior of the primate. All science must start with some assumptions as to the ultimate analysis of the facts with which it deals. These assumptions are justified partly by their adherence to the types of occurrence of which we are directly conscious, and partly by their success in representing the observed facts with a certain generality, devoid of ad hoc suppositions. The general theory of the vibration of primates, which I have outlined, is merely given as an example of the sort of possibilities which the organic theory leaves open for physical science. The point is that it adds the possibility of organic deformation to that of mere locomotion. Light waves form one great example of organic deformation. At any epoch, the assumptions of a science are giving way when they exhibit symptoms of the epicyclic state from which astronomy was rescued in the 16th century. Physical science is now exhibiting such symptoms. In order to reconsider its foundations, it must recur to a more concrete view of the character of real things, and must conceive its fundamental notions as abstractions derived from this direct intuition. It is in this way that it surveys the general possibilities of revision which are open to it. The discontinuities introduced by the quantum theory require revision of physical concepts in order to meet them. In particular, it has been pointed out that some theory of discontinuous existence is required. What is asked from such a theory is that an orbit of an electron can be regarded as a series of detached positions and not as a continuous line. The theory of a primate or a vibrating pattern, given above, together with the distinction between temporality and extensiveness in the previous chapter, yields exactly this result. It will be remembered that the continuity of the complex of events arises from the relationships of extensiveness, whereas the temporality arises from the realization in a subject event of a pattern which requires for its display that the whole of a duration be spatialized, that is, arrested, as given by its aspects in the event. Thus realization proceeds via a succession of epochal durations, and the continuous transition, that is, the organic deformation, is within the duration which is already given. The vibratory organic deformation is in fact the reiteration of the pattern. One complete period defines the duration required for the complete pattern. Thus the primate is realized atomically in a succession of durations, each duration to be measured from one maximum to another. Accordingly, so far as the primate as one enduring whole entity is to be taken account of, it is to be assigned to these durations successively. If it is considered as one thing, its orbit is to be diagrammatically exhibited by a series of detached dots. Thus the locomotion of the primate is discontinuous in space and time. If we go below the quanta of time which are the successive vibratory periods of the primate, we find a succession of vibratory electromagnetic fields, each stationary in the space-time of its own duration. Each of these fields exhibits a single complete period of the electromagnetic vibration which constitutes the primate. This vibration is not to be thought of as the becoming of reality. It is what the primate is in one of its discontinuous realizations. Also, the successive durations in which the primate is realized are contiguous. It follows that the life history of the primate can be exhibited as being the continuous development of occurrences in the electromagnetic field. But these occurrences enter into realization as whole atomic blocks, occupying definite periods of time. There is no need to conceive that time is atomic in the sense that all patterns must be realized in the same successive durations. In the first place, even if the periods were the same in the case of two primates, the durations of realization may not be the same. In other words, the two primates may be out of phase. Also, if the periods are different, the atomism of any one duration of one primate is necessarily subdivided by the boundary moments of durations of the other primate. The laws of the locomotion of primates express under what conditions any primate will change its space-time system. It is unnecessary to pursue this conception further. The justification of the concept of vibratory existence must be purely experimental. The point illustrated by this example is that the cosmological outlook, which is here adopted, is perfectly consistent with the demands for discontinuity which have been urged from the side of physics. Also, if this concept of temporalization as a successive realization of epochal durations be adopted, the difficulty of Zeno is evaded. The particular form which has been given here to this concept is purely for that purpose of illustration and must necessarily require recasting before it can be adapted to the results of experimental physics. End of section 8.